Hi everyone, welcome to our Halloween themed or fall themed, however you want to think about it, webinar. We'll get started in just a moment or two. Give folks a couple of minutes to join and we'll get going. While we're waiting to get started, as folks are joining the meeting, maybe in the Q&A, if we could just have people put, if they use NOLOCK, if this is a hint that is used a lot in your environment, or the read uncommitted isolation level. Some folks use it just for reporting, so just it would be kind of fun to get a feel for who's out there and how topical this is for you. Webinars are always fun because you're talking to a screen and can't really see who's out there and what they're doing. So that would be nice. Reporting team uses NOLOCK. Sounds like we have at least one person who says their reporting team uses NOLOCK extensively. All right, well, let's go ahead and get started. And we've got a few folks out there. I can't see the count right in front of me, but my name is Randy Knight, for those who don't know me. And I am the founder of SQL Solutions Group, which will tell you a little bit about me and about the company in a bit. I also have on the line with me Scott Klein, another of our consultants, who will be watching the Q&A. And so if there's any questions or things, he's actually sitting here in the office with me, 6 feet away, of course. And we'll get you taken care of. Okay, Nightmare on NOLOCK Street. So again, my name, just a little bit about me. My name is Randy. I am a Microsoft Certified Master, if you happen to know what that is. It's a relatively rare certification. Microsoft had their advanced certification program that they canceled about, it's probably may have been 4 or 5 years now, but there was Microsoft Certified Master, Microsoft Certified Architect, and it's similar to like a CCIE, VMware vExpert, things like that, a higher level type of certification. I've been doing IT and working with databases for way longer than I like to admit, so I just say 30 plus years. Started with SQL Server in 1997 version 6.5 and have done tons of fun stuff with it since then. Obviously, I've seen lots of changes in the product. Prior to starting this company, I spent 6 years as a technical architect or database architect for Match.com, which was definitely, I like to say, the most interesting data that I've ever worked with. I also have a member of my team, Jared Kirkpatrick, who I worked with at Match.com. And when we introduce ourselves and mention that, it's very important for me to be very clear that we met while working at Match.com. Because if we say at Match.com, that sounds a little bit too much like on Match.com. So we're both happily married to other people. So, all right, SQL Solutions Group. We're a Microsoft certified full service boutique consultancy, I guess is the term that they tend to use. We're small. We have 5 employees. We just celebrated our 10th anniversary this month, so that's pretty exciting, pretty big milestone. We are based technically in Las Vegas. We have folks in Las Vegas. I'm actually sitting here in Washington State, not far from Redmond, Scott and I, and we've got clients and consultants all over the country. We have in the past been frequent presenters at SQL Saturday, Past Summit, SQL Intersections, different events. Of course, everything is virtual now. We're looking forward to getting back to that. Just a couple slides about us for the sales pitch, as it were, and then we'll jump into the content. We have a remote DBA managed service that a lot of our customers like for fractional DBA ownership, or just kind of plugging into our system for on-call monitoring, coverage, things like that. We do health checks, and then of course we do just time and materials based consulting, or we say time and materials, there's not a lot of materials, but just billable hours, as it were. All right, enough of that. Let's move on to the presentation. So in this hour that we have, which is not a lot, talk about concurrency, how SQL Server manages concurrency, locking, and we'll talk about locks, blocks, and deadlocks, and particularly the differences between each of those things, because there's a lot of confusion out there. We'll do a quick review of the standard isolation levels that SQL Server has available to us and how that impacts locking. We're going to do a quick review of page splits, because when we get to what some of the real dangers are using the NOLOCK hint, the page splits are the cause of some behavior that may be surprising. It tends to be surprising to most people when they see what that can cause. So we're going to review how those work, and then we'll dive into the dangers of NOLOCK. All right, ACID. Anybody who's ever read a book or taken a class in any kind of relational database likely has heard this term, ACID. It's an acronym. It stands for atomic, consistent, isolated, and durable. These are the characteristics of a database management system, and specifically of our transactions, of our data, that need to exist in order for it to be a transactionally consistent relational DBMS. In recent years, of course, the advent of NoSQL, big data, things like MongoDB, Cosmos DB has been very big, and those have their place. What I always like to say is just be aware that when you're using one of those databases, you have dropped ACID. That doesn't work nearly as well when I can't hear all the uproarious laughter that I know I'm sure that caused. So, all right, so isolation is the piece of this that we're focusing on today in a multi-user concurrent system where we've got lots of folks reading the data, lots of folks modifying the data at the same time. How do we manage isolation? All right, locking defined. So the way we manage that in SQL Server is through locking. The idea is, in a multi-user system, it's great for us to have even, thousands of users in the same database using that web application that's connected to the database, whatever the case may be. But when it comes to modifying data, we need to ensure that only one user, or one session technically, at a time can modify a given piece of data, a row, a column, a table, whatever the modification happens to be. And that's the isolation part of this. This is how SQL Server handles isolation. We are going to take a pretty high level view of locking here because we only have an hour to cover all of this. Locking is much more complex than we're going to talk about here, but we're just kind of covering the basics. Categorizing the types of locks we have in SQL Server, there is something that we would call, from a just English standpoint, read locks, which SQL Server calls shared locks. We'll see in a moment why they're called that. And then read locks are concurrent, meaning multiple users can have shared locks on the same resource at the same time, which makes sense because we're reading the data, we're not changing it. So if there's 10 of us all reading the data in that table at the same time, no big deal. It only matters when we start to change data. Then we have write locks, which write locks can be called update locks and exclusive locks. And again, some may be watching this and saying, wow, there's a whole lot of other types of locks. And there is. We're trying to simplify this for the purposes of this presentation. An exclusive lock is what it sounds like. When you're going to write to the database, change a resource being a row in a table, an entire page, an entire table. Maybe you're doing data definition language where you're actually going to change the data. You have to have exclusive access to that resource at the time you make the change. And so shared locks for reads and exclusive locks for writes are very appropriately and intuitively named. There's also the concept of an update lock. And the easiest way to think of that is that an update lock is a lock that wants to grow up and become an exclusive lock, right? So I come along and I say, hey, I'm going to change this data. I get an update lock. And once I can get an exclusive lock, meaning everybody else's locks have been released, that lock turns into an exclusive lock. Write locks are isolated because they have to be. And then the last topic here on locking, lock levels. I've been using the term resource a lot to refer to what is being locked. That could be an entire table. It could be a page in the database, which is 8 kilobytes of SQL Server data. Our entire database is divided into 8 kilobyte pages, and our rows live on those pages. How many rows live on a page depends on the size of the row, meaning the width of the row, right? If you have a row that averages 1K in size, which is a very large row, you're going to get about 8 rows per page. We also can see locking at the row level, where we even go more granular than the page. Most of the time, page locks are what we're going to see because SQL Server needs to balance the locking overhead with managing concurrency, right? So if we have hundreds or even thousands of rows per page in that 8 kilobytes, it's much more efficient to lock the page than to lock one row at a time. Okay, the next concept is lock compatibility. What we can see here in this graphic is we have the little boy there who is a reader. He's reading his book. And we have the little girl who is a writer. She's writing to something. And in the middle, we have a page in the database. And so if we think of the reader as our shared locks and we think of the writer as our exclusive locks, which of these types of locks will prevent other activities? Easiest way to think of this, readers block writers. So while I am reading that resource, nobody can write to it because remember, they need an exclusive lock and they can't get an exclusive lock if I have a shared lock. We can also say writers block readers, meaning if she is writing to that page and has an exclusive lock, he will not be able to read that data. And then of course, writers block writers. If one user is writing to the data page, only one user at a time can be doing that. And then of course, from a compatibility standpoint, readers do not block other readers. So again, that's why they're called shared locks and exclusive locks. Okay, by the way, as we move through this, if you have questions, things that you want to cover, go ahead and put them in the Q&A. Scott is watching that and will kind of give me a heads up that there are some questions, and we'll interrupt and cover those as needed. Okay, so we've talked about locks. The next topic is blocking. And this is one most people who have been around SQL Server very long at all in a busy database environment has experienced, whether you know it or not. Blocking is defined as user A has a lock on a resource. So we're saying user A has a lock on resource X. User B needs a lock on resource X. And the most important part, the locks are incompatible, right? Thinking back to our lock compatibility, if user A and user B are both trying to read the data from resource X, that's no problem. The locks are compatible. They can both have those shared locks at the same time. But if they're not compatible, user B is going to have to wait until user A completes their activity and releases their locks to be able to do what they need to do. So that's described as user A is blocking user B. Now, this is what's called a block. The most important thing about blocking to understand is this. This is normal behavior. This is how SQL Server works by design. We have to have locking. We have to have blocks taking place in order, or not, we don't have to, I guess, but anytime in a busy system where there's potentially multiple users trying to access the same data, to write the same data, we're going to have blocking. The issue becomes when we have excessive blocking, and that is typically defined as a block that lasts too long to the point where it begins to impact users. So then the question becomes, well, what's excessive? And like so many things in SQL Server, the answer is it depends. An excessive block in an OLTP system with thousands of transactions happening might be 2 seconds. That's too long because there's just so much activity going on. In a batch-based system where there's big set operations and things going on, we could have blocks that last 5 minutes, 10 minutes, however long, and that's okay as long as they eventually complete. So it's really going to depend on your environment. Of all the things that we monitor in our managed service, our remote DBA managed service for our customers, blocking is probably the thing we spend the most time on tuning the thresholds for alerting, because it just depends on that environment and what is considered normal or acceptable. The other thing that I like to point out about blocking is that many times concurrency related problems like blocking surface themselves as performance problems, right? When user B is sitting around waiting in their application, they just clicked OK or whatever the case may be, they're seeing an hourglass, right? And they're going to say, man, it took 30 seconds to write this one record. And in reality, what happened is they spent 30 seconds waiting for user A to release their lock, and it didn't take any time at all. So many times the system is slow, the system is down. One of the first things we look at is concurrency. Do we have excessive blocking going on? We also can get the concept of a blocking chain. So our first example, user A and user B, was pretty straightforward, but we can have user A blocking B, B in turn is blocking C, and so on, right? And we've seen situations where blocking like this, these blocking chains, can essentially cause an outage from the end user's perspective, because these blocking chains get so severe and impact so many resources, so many users, that the system really just becomes unusable from the user perspective. Okay, last topic, and then we're going to get into some demos. Deadlocks. So we've talked about locking. We've talked about a block. This last thing is a deadlock, which is something similar to blocking, but even worse. A deadlock can be defined as user A and user B both have locks that prevent the other's transaction from completing. Okay, so in our example of blocking, user A had a lock on a resource that user B needs. User B just sits there and waits until user A is done. In a deadlock situation, user B also has locks that prevent user A's transaction from completing. So they're in this deadlock situation. Neither transaction can complete without the other one completing. This has to be a situation that will never clear itself. So in a normal blocking situation, whether that block lasts 2 seconds or 2 days, from SQL Server's perspective, it sees that as something that will eventually resolve itself. Eventually, user A will release their locks and user B will be able to do their work. And we're going to see examples of both blocks and deadlocks in the demo in a moment here, and this will become a little bit more clear. But in a deadlock situation, we have what we call a cyclical block that cannot resolve itself. Both users are going to sit there waiting forever. So SQL Server has a mechanism to handle that called deadlock detection. And what it's going to do is it's going to choose one of those connections as a victim, and that's the actual technical term, is the deadlock victim, and it's going to kill that connection so that the other one can complete. Obviously, in our applications, having connections just get killed like that is not something we ever want to see happen. So the biggest thing I like to point out on deadlocks is that this is not normal behavior. And over the years, I've found that there's a lot of misconceptions out there and confusion about the difference between blocks and deadlocks. And so we'll have, maybe it's an ISV with an application that we're supporting, whatever the case may be, and we're seeing lots and lots of deadlocks, and they say, oh, that's normal behavior. And the answer to that, well, it may be normal behavior in your application, but that's because it's full of bugs, because this really should not ever happen. Okay, that brings us to our first demo. We're going to look at 3 things. We're going to look at how can I see lock information that is in place. We're going to create a block and see how that works. And we're going to create a deadlock. All right, so let me switch over to SQL Server Management Studio. And I've got a query here. We're using the AdventureWorks database like everybody else. And the reason that I do that is because if you download the scripts from these demos and you have the AdventureWorks database, you can recreate these scenarios yourself. But what we're doing is we're querying a dynamic management view called sys.dm trendlocks, which just gives me all the locks that exist right now. You can see, and then I'm joining it to some other dynamic management objects just so that we can normalize it or denormalize it, right? Database name, the object name as opposed to just the object ID and so forth. So on this screen right here, you can see the last time I ran this query, we had 1 lock. Keeping in mind this is an isolated instance here on the computer I'm using for the presentation. We can see that the session ID or the SPID was 65. The database that connection is connected to is AdventureWorks. The locked object, sales order header big. We can see the resource type, and this is where it could be a page, a row, a key. Typically pages and keys are what we're going to see. We see the type of lock, an S being a shared lock, the SQL statement that took the lock, and the resource description, which is an identifier for the page, right? So this is saying on data file 1, page number 118967 is what we have a shared lock on. So whether it's in the row from this query or not, if someone tries to get an exclusive lock on that page, they're going to be blocked. All right. Well, that's from a little bit earlier when I ran this. If I run this query now, there will be no locks because this is an isolated system. But as we look at this, what we're going to do is go to other connections and generate some activity and come back and see what is being locked. All right, and as we do that, one of the things that we want to do is focus on this resource description, because it may look like nothing is changing, but in fact, this page identifier will change. All right, so if I execute this right now, no locking is taking place. There's no activity on this SQL Server right now. Okay, so now we're going to go to our database, VentureWorks. And the first thing I'm going to do is ensure that this database is using the default read committed. So read committed is the default behavior of SQL Server. We're going to talk about isolation levels in a moment and what the difference is. But I need to make sure that I'm using read committed. So we have our set transaction isolation level read committed. I also want to make sure that snapshot isolation is not enabled for this database. And we'll talk about what that is briefly after this demo. All right, snapshots off, we're in read committed, we're good to go. The way the default behavior of the read committed isolation level works is SQL Server will grab a shared lock on a resource only for as long as it needs to read that resource and ensure that it hasn't changed, right? So in order to understand this, we need to realize that queries don't execute all at once in a split second, right? Especially if it's a long running query that reads many, many pages, it's going to lock a page, read it, release the lock, and we'll see it locking different pages at different times as it's processing that query. So right here, if I execute a query against a small table, this entire table is on one page. When I execute that query, I got my data back, but what happened behind the scenes is I got a shared lock, read the data, released the lock. And I'm not fast enough to go over here and see that lock before it gets released. So what I have here is I have a table with 2 million rows in it. And I'm going to say select star, so select all rows, all columns, no where clause, and I want to query and read all 2 million rows. That takes about 30 seconds on this system, which is why we're doing this. So again, right now, there are no locks. I'm going to execute this query, and it's going to start reading those 2 million rows. And if I go back here and execute this, we can see a shared lock on this resource, 123701. And as I execute this continuously, it's the same query that's causing these locks, but we can see that resource description changing. At times, as we execute this, like the one we just saw, there will be no locks because I happen to get there in between pages. At times, we could potentially see multiple pages, okay? So we can just kind of think of this as SQL Server scrolling through those pages, lock, read, release the lock, lock, read, release the lock, lock, read, release the lock. And here I have my 2 million row data set back. So that's how read locks work. Okay, let's take a look at data modification. Anytime we're doing data modification, of course, we have a transaction. And keep in mind that you always have a transaction. Whether you explicitly say begin transaction and commit or rollback transaction, or you don't, if you run an update statement without saying begin transaction, you have what's called an implicit transaction where the entire transaction is one statement, okay? So we're going to begin a transaction, and we're going to take this Human Resources Department table. We see Department ID 1 has a group name of Research and Development. We're going to change that to R&D. So we'll go ahead and update that row. We have not committed our transaction yet. So if we go back here to our locks, what we're going to see are exclusive locks. We have an exclusive lock on the key that identifies that row, department ID 1 in this case. We also have something called an intent exclusive lock on the entire page. And again, we're not getting into that level of detail on locking, but we can see that exclusive lock will be there for as long as I keep this transaction open, right? It's not going anywhere. Okay, so here I am, I've run my update statement. If I query that data in my session, it comes back, and it comes back with the group name of R&D, the new name. This is as expected because I'm the one that changed the data. I should know what it is. But anybody else should not see R&D until I have committed that transaction and the transaction has been hardened, which means it's now durable, has been written to disk. So that's the durability part of ACID. Okay, going to another connection, and we've got another user in this database, read committed isolation level, who wants to read that row. And I execute that select statement. And what I have now is a block. So I'm going to sit here in hourglass, right? We can see my query, 8 seconds, 9 seconds, 10 seconds, right? It's going to run forever until the locks from this session have been released. Going back to my locks, the exclusive lock is still there. We also have this session ID 67, which has a shared lock, which can be a little bit misleading because it's actually not able to read the data yet. What that shared lock does is put it next in line, right? So if SPID 65 releases its lock at the same time as SPID 68 wants to change the data, SPID 68 will be blocked by SPID 67, and on we go. That brings us to NOLOCK. So one of the things that we call this, when I can read this data and I see the R&D versus research and development, so I see the new data and the transaction has not been committed, is that I'm reading dirty data. It's dirty because it has not been written to disk. It is not permanent. This is not a permanent change to the database until we commit the transaction. So one of the terms for read uncommitted or using the NOLOCK query hint is dirty reads, meaning I can read dirty data. So if I execute this query with NOLOCK, go ahead and stop that. Actually, before we do that, I'm gonna go ahead and run this. I'll come back to that. If we execute this with NOLOCK, we get group name R&D. It comes back immediately. It was not blocked like this read committed query was. And wow, that looks great. I've just discovered the SQL Server turbo button, right? Well, what we're going to see as we get into isolation levels in our next demo is that there are, like so many things that seem great, there are some unintended consequences of this hint that are pretty nasty. Okay. All right. So I'm going to go back and execute the read committed query again so that I have the block, which is what we saw here. I'm going to go here to this guy. I could commit or roll back the transaction. I'm going to roll it back. Once I have done that, this query completes immediately because I committed the transaction, released my exclusive lock, and now this session was able to get its shared lock and read the data. And of course, it gets the committed clean version of the data, research and development, because I rolled back the transaction. And if I go back to my locks, of course, there's nothing locked right now. Okay, Scott, do we have any questions yet at this point? Okay, great. We will move on to deadlocks. So we've seen how a block works and how we create a blocking situation. A deadlock just takes it to another level. We're going to work with two tables this time in the AdventureWorks database, the employee table and the department table. I am going to begin a transaction. And notice this is an update without a where clause. So I'm going to add the suffix _B to every department's group name. So I'll go ahead and execute that. It comes back and tells me 16 rows were affected. If I look at the data here, I see the B tagged on the end of each of the groups. And of course, if I go look at the locks that are in place, lots of exclusive locks. Again, 16 rows is the entire table. That's going to fit on one page. So we see the intent exclusive lock for the page and the actual key lock for each of those 16 key values that identify the row on that page. Right? And it's going to hold that exclusive lock until I commit or roll back the transaction. Okay, now we're going to go over to a different session. User B begins a transaction and says, I'm going to update the employee table and set the gender to male for all employees. Oops, I need to use AdventureWorks. 290 rows affected. That's going to become important in a moment here. All right, so what locks are in place now? If we go look at our locks, we see our session 69 has all of those exclusive locks on the department table. Session 70 has all of those exclusive locks on the employee table. No problem, right? These users are not conflicting with each other in any way. However, we're now going to go back to, actually we'll go back here. And as part of my transaction, user B says I also need to update the department table and set the modified date to get date. When I execute this part of the transaction, I'm going to be blocked, right? I've created a blocking situation. Remember that user A has every row in the department table has an exclusive lock. User B wants to change that data. Okay, we still don't have a deadlock. We have a block. Right, so we see all those same locks. We do see one thing different though. If you'll notice, when we go down, there's all those exclusive locks from department and employee. But if we look and we go down here, we say, wait a minute, here, session ID 70 has an update lock on the department table. Remember I said an update lock is a lock that wants to grow up and become an exclusive lock? Basically what we're saying is that once session 69 releases its exclusive locks, I'm going to get one. All right. Again, this is a block. This can go forever. SQL Server has no way of deciding whether or not it's going to complete successfully. All right. So that was deadlock B. Now we're going to go back to user A, and we're going to say within my transaction, I need to update the employee table. This is what's going to create the deadlock, because user A is in a transaction, has an exclusive lock on department, and wants an exclusive lock on employee. User B is in a transaction, has exclusive locks on employee and department. So we're never going to get the locks that we're looking for, okay? So when I execute this, it's going to create a deadlock. What's going to happen is SQL Server is going to choose which of these two sessions to be the victim of that deadlock. So I'm going to go ahead and execute that. And it takes up to 5 seconds because there is a thread, a system connection that SQL Server has called the Deadlock monitor that runs every 5 seconds by default to find deadlocks and choose a victim. So this transaction completed, which means user B was the victim. And the error message that user B actually gets is transaction was deadlocked on lock resources with another process and has been chosen as the deadlock victim. Rerun the transaction. And many times we even see that error, that exact error text surfaced up to the user, which is disconcerting to many users. What does it mean? You know, deadlock victim. What did I do? I broke the system, right? Okay. If we had a lot of time to talk about deadlocks, we could look at deadlock graphs and talk about all the different things that can cause deadlocks. But for purposes of this webinar, we're just going to roll back these 2 connections, release all of our locks, and move on. So now we're back to no locks are in place. Okay, so we looked at using the query, which will tell us what resources are being locked and which types of locks. We created a block, we created a deadlock. Transaction isolation levels. Transaction isolation levels are what determine the behavior SQL Server will use for a given session. It can be at the database level, the session level, or with hints even at the query level. These are ANSI standards. So our isolation levels that are available in SQL Server are not something Microsoft made up necessarily. These are part of the ANSI standard. And there are 4 isolation levels that use locking. There's a 5th one called snapshot, which we'll talk about just briefly, but it's a little bit different mechanism. So we have level 0, level 1, level 2, level 3. Read uncommitted, read committed, repeatable read, and serializable. You'll notice read committed is strike through. That's because read uncommitted isolation level is the same as using the NOLOCK hint, and we really don't want to do that. And we're going to see why in just a moment. Read committed is the default behavior. That is the what we just looked at in our demo, where we hold our shared locks just long enough to read the data, and then we release it. We have repeatable read, which allows us to actually use a transaction for a select statement and tell it, I want to hold my shared locks open until I commit or roll back the transaction. We have a question. How does SQL Server determine which is the victim on a deadlock? That is a great question. There are 2 ways that works. There's something, a session option that you can set called deadlock priority, which can be low, medium, or high. So if the 2 connections have a different priority, whichever has the higher priority will win. If the priority is the same, what SQL Server does is it looks to see it when it kills one of those 2 connections, it's going to have to roll back any changes that have been made, right? It's going to have to hit the undo button and remove that back out of the transaction log. So it kills the session which is using the least amount of transaction log space. So that's how it works. All right, repeatable read. Again, we're going to have a transaction, hold our locks within the transaction. Serializable, we're actually going to go a step further. We're going to say, I'm going to lock the entire range of keys, right? Because in repeatable read, we still have a situation where we can potentially introduce additional data on a new page into our result set that fits our criteria in our where clause. Serializable will prevent that. So what happens is, as we go from level 0 up to level 3, we are creating much more locking that lasts longer as we go higher in those levels at a cost of less concurrency. The lower the isolation level, the more concurrency, the less locking. That finally brings us to snapshot, which is essentially, rather than using locks for reads, what SQL Server does is it uses something called the version store in tempdb, and it will store a copy of the updated row. So when someone comes along and they are in a transaction, they have an exclusive lock, SQL Server uses this version store so that when someone else comes along and wants to read that data, between the version store and the actual data, it can read the committed clean version of the data, even if there's an exclusive lock in place. So it allows for much more scalability than read committed without the downsides of read uncommitted. Now, if we had time to go into snapshot, of course, there's a cost associated with that too. It's not a one size fits all, but we should be using it more than we are. Okay, last thing before we get to the NOLOCK demo. Remember that SQL Server stores data on pages, 8 kilobyte pages. And so as we're adding data to our database, that data is coming in and being added to that page a row at a time. And normally, when a page fills, it's going to put the next row on a new page. Keep in mind that your indexes, your clustered index for the table itself, non-clustered index for the leaf levels of a non-clustered index, determines the order of the rows on those pages. So if I needed to insert, for example, so we've got data row 1, 2, 3, and 4, and suppose that's an integer key to our clustered index, or well, let's say it's a float. And I go to insert row 2.5. SQL Server needs to put that between row 2 and row 3. Row 3 doesn't fit. So row 3 is going to get moved to the next page. Row 4 is going to get moved down, and so on, right? That's a page split. The reason that's, actually, let's come back for just a minute. Causes of page splits, if we are inserting data that, as in the example I just gave, that the index keys are such that it has to go in that order. Also, variable length data, varchar, nvarchar, var binary columns. If I have say it's a varchar 2000 characters, and most of my rows have 10 characters in that column, my data will be much more dense, meaning more rows fit on a page. So if I have a page that's full with those 10 characters, rows, and I go update one of those to 500 characters or 1,000 characters or whatever the case may be, that row no longer fits on that page. So that's going to cause a page split. So what page splits are caused by effectively, this is also sometimes called data movement in a clustered index. And the data is moving around on us. Without locks, how can SQL Server know that that row 3 moved from the first page in our diagram to the second page in our diagram? It can't. So if we think back to our 2 million row query, where we read all of that data, and we saw it scrolling through lock a page, release, lock a page, release, lock a page, release. It could have a brand new page like this that didn't exist, was not part of this result set at the time that we executed the query. So this row is missing from our result set. So that would be omission. Or in the other example, when row 3 moved from 3 to 4, suppose we read, or from this page to this page, suppose we read page A, we read row 3, and then by the time we read page B, row 3 had been removed from page A and written to page B. We're going to read that row twice, and we're going to end up with duplicates in our result set. This is the real danger, or in the parlance of this webinar, the nightmare of NOLOCK, is that you don't really know if your data will be correct. So let's take a look at a demo. What I'm going to do here is we have a table that is a very poorly designed table, which was created for the express purpose of causing page splits so that we can illustrate this. So this table is called Evil NOLOCK, and it has, I believe, exactly 100,000 rows in it. So if I say select count from Evil NOLOCK, I get 100,000 rows. And what I actually have here is I have a loop which waits 300 milliseconds, counts the rows in the table, writes that to a user settable performance monitor counter. And you may or may not be aware that that's something that exists within Performance Monitor. If I go to my Performance Monitor, we can see I have one counter on my graph, SQL Server user settable user counter 1. That value corresponds to a store procedure. So the value is 100,000 because the last time I called that store procedure, the value was 100,000. Exec SP user counter 1. Okay, so what's going to happen is I'm going to kick off this loop. Every 300 milliseconds, it's counting the rows in that table using the NOLOCK hint and updating that counter. And I'm also printing out the value here so we can see it that way as well. So we're seeing 100,000 every time, which we had darn well better see 100,000 every time. We haven't changed any data. We have not inserted or deleted rows, so there should be 100,000 rows in that table. Now what we're going to do is we're going to go back, and if you look at the structure of this table, again, this is a very poor design. It has a clustered index on a column called Sum Data, which is a GUID. Well, if you think about what a GUID looks like, by definition, every time I change a GUID, insert a row, update a GUID, that data is going to have to move. It's going to cause page splits. So now what I have is I'm going to go in another loop, and every 300 milliseconds, I'm going to update every GUID in that table. Again, this is not something that you would ever do in the real world, but it's a good way to illustrate that page splits are taking place. All right, so that's running, and we should start to see some output here in a moment, right? This is still running. Let's go take a look at our performance monitor. And what do we see here? We see a few places where it gets the right value, the 100,000, but we have cases like this one, right, where we were up to almost 100,200 or a little bit higher. We see some where we're at 99,800. So we have cases where we are either double counting or missing hundreds of rows from our result set because of the way they're moving around. And this is the real problem with NOLOCK. And what I hear from many people are things like, oh, well, we know the data is dirty, and if the transaction gets rolled back, the data won't be right. We can live with that because that's pretty rare for the performance gains of using read uncommitted or the NOLOCK hint, without realizing that this is what's going on. And if you think about the fact, I think someone mentioned this in our little survey at the beginning, who is it that tends to use NOLOCK a lot? Reporting teams, right? Reports tend to use a lot of aggregates. So we're doing things like this count or a sum or an average or whatever the case may be, and our data is completely wrong when we have this going on. This is the nightmare on NOLOCK Street. This is why I say we should almost never use this. There are lots of different things we hear this called. So here we're riffing off Romeo and Juliet here. NOLOCK by any other name will still stink. Read uncommitted is the technically correct name for the isolation level. Sometimes this is referred to as dirty reads. And then there are some other things that I and others use to describe what we get. Who cares if it's right? My data doesn't really matter, does it? Close enough. Actually, this report is more of an estimate, right? If I'm doing financial reporting using NOLOCK and you're calculating my bonus this way, well, I sure hope that my bonus got calculated at one of these peaks instead of one of these troughs, right? The data is just not right. There's your data. Really what we're saying here, your data does not equal a horseshoe or a hand grenade, or in other words, close enough does not count. And that's, I realize we may have some attendees from different countries. There's an American saying that close only counts in horseshoes or hand grenades, meaning, you know, if you get you win if you get close. Anything else, we need it to be right, right? So unless you are doing something where an estimate is actually okay, you should not be using this hint ever. So let's talk about ways, the right way to prevent some of these concurrency related issues. Short transactions is the #1 thing that I can do. We saw how exclusive locks work. I need to get in, get out, right? So if I have a bunch of work to do to figure out what I'm going to modify, don't do that inside the transaction. Do that separately. Begin the transaction, modify, whatever you need to, commit the transaction. One of the things that will help with that as well is having the appropriate indexes. This could be too many indexes, so that we're taking a lot longer to write our data than we should, or inappropriate indexes. And then finally, if you have concurrency related issues and you've done those things and you think you need NOLOCK, you really should be investigating using RCSI, read committed snapshot isolation, to effectively just get rid of read locking is what it does, so that the only blocks will be writers blocking writers. Scale out is another big one. Again, the reporting workload in an OLTP environment is something that we see quite often, and that's where the use of NOLOCK happens a lot. It's going to be much better whether it's, you know, log shipping, replication, read-only replica in an availability group. However, we need to have a separate copy of that data for our reports in a read-only environment so that we can separate those queries out, scale out our workload. As an example, when I was at Match.com, as I mentioned, we had what was called a write server, where all the writes took place, and then that data was used transactional replication to replicate out to, how many depended on peak and things like that, but it could be up to 16 copies of the data, read servers that were load balanced, right? So that all the reads were taking place there and the writes were in one location. Okay, so quickly to summarize, we need to minimize blocking with short transactions. The other thing to remember is it may not be apparent to me when I'm updating data. I may have a simple update statement or delete statement. How much is actually going on behind the scenes? How many non-clustered indexes are there that we need to update? Do I have triggers? All that activity that happens in the trigger is going to happen within the transaction. Do I have cascading constraints? where if I delete a row from the parent, it's going to delete any rows from the child of that constraint. So we need to be aware of everything that's happening when we execute that statement. Sounds like we have another question. You can just say it, Scott.
RCSI over read uncommitted trade-offs.
So trade-offs, so I would say the biggest thing is that with RCSI, your data is right. and that sounds sarcastic, and it kind of is, but I just don't trust the data that comes from read uncommitted. The cost of RCSI is the version store in TempDB, because when we update data, in order to make sure that we're going to be able to read that data before the transaction gets committed, we're keeping a copy of that in TempDB. So there is a cost. You need to make sure that your TempDB is tuned appropriately, that it's on fast storage, that you have the appropriate number of files. Depending upon the version of SQL Server, there's some trace flags that you want turned on. But these days with TempDB almost always on SSD or even NVMe, there's not a lot of environments where I would not recommend using RCSI. There certainly are edge cases, but you know, the architecture in those environments is going to be completely different. So
one more snapshot isolation level looks good. Looks like a good candidate for reporting in an NOLOCK database.
Absolutely. Yep. So the question was, snapshot isolation looks like a good candidate for reporting in an OLTP database, and the answer is yes. One of the things to be aware of, so Microsoft introduced RCSI in SQL Server 2005. One of the things, if you're concerned about that, to be aware of, Oracle from the get-go has used they call it row versioning, I believe, but they've used that same technique by default. In fact, I had a friend of mine who wrote like 15 books for Oracle Press, Oracle Master, all that good stuff, telling me that he would go so far as to say there's no such thing as a read lock in Oracle, right? So this is not unproven technology. We've had it in SQL Server for 15 years now, but even separate from that, this is technology that works and that's used. Great questions. Okay, concurrency, just to review, the locking is normal. You don't want to get rid of locking in your database. I hear that sometimes. We're having a locking problem. How do we get rid of locking? Well, you don't. Locking is normal until it becomes excessive. Deadlocks are not normal behavior. That concludes our webinar. Hopefully that was useful. And again, we have a little bit of fun with it at the Halloween season with the Nightmare on NOLOCK Street, but it really can be. And I hope, if nothing else, attending this webinar, this one right here, shows you the dangers of using NOLOCK. The last thing, well, a couple things, some resources that are out there for you. SQL Server community is big on Twitter, some different Twitter hashtags. There's my Twitter handle. Pluralsight has some really great courses that go into great detail on this. And then the last thing, here's my contact information. I also wanted to point out to everyone that we have a kind of fun little contest going right now. Share a SQL trick, get a treat. This is on our website, SQLsolutionsgroup.com. It's the most recent blog article. And there's a short video, about 2 minutes. Scott Klein shows us a trick that he likes. And what we're saying is just, if you have your favorite SQL trick, go ahead and put it in the comments. We've gotten a couple already. And if you comment with a trick, number one, you're going to get a SSG face mask, keeping with the times with our swag. We have masks that we will send out. And you'll also be entered in a drawing for a $50 Amazon gift card. So share a trick with us and we'll give you a treat, is the idea behind that one. And that goes till October 31st. Again, thank you. I know we're a little bit over time. I've got a minute if there are any other questions. Also, of course, contact information here. If anybody would like to reach out to me directly via email or LinkedIn, Twitter, you're certainly welcome to do so. So we'll leave it there and hang out for a few minutes to see if there's any questions.
We talked about the reporting. Can it be combined with whatever isolation level the UI is using? For instance, setting it on the report SP.
So the question is, can the isolation level, can you just read it to me? Just the.
Yeah, can it be combined with whatever isolation level the UI is using? For instance, setting it on the report SP. And SP is store procedure.
Store procedure. Yes and no. Read committed snapshot isolation is set at the database level. One of the questions that I get quite often, similar to this, I think that will answer this, is what if I have NOLOCK hints all throughout my code base? Can I turn on RCSI and it will stop using the read uncommitted? And the answer is no. You're going to have to go change all your code, because isolation levels exist at multiple levels, right? You've got the isolation level that's set for your database, and then you also have whether or not you're using RCSI for the database. Then you have the set statement that for a given stored procedure or for a different session, we can set our isolation level. And then finally, you have query hints, like NOLOCK as an example, that you can affect the way a specific query works. So the answer to the question is yes. In a given stored procedure, you can set the isolation level for that stored procedure, and off we go. Pull up the Q&A right here. See if there's anything else.
Go to published.
Published. Got it. All right. So there we go. So yeah, Jacob Case, there was the RCSI overread uncommitted. I agree with you completely on that one. And then the reporting. So. All right, well, I hope everyone has a happy and safe Halloween, if that's something that you celebrate. Everything is very different this year, of course, with quarantines and lockdowns and social distancing. But hopefully this was of value to you, and feel free to reach out to me or to us as a company with any questions or things that you may need. Have a great one.